As we saw earlier, the base adenine can form 2 hydrogen bonds with thymine in DNA, and adenine forms 2 bonds with uracil in RNA. So the building blocks are going to be the uridine triphosphate for RNA. You can see the oxygen down here on the ribose, and then the thymidine triphosphate for DNA with the missing oxygen here on the deoxyribose. And then adenosine triphosphate is the purine base here versus the pyrimidine bases on the other ones, uridine and thymidine. Adenosine or adenine, the base, does not have a hydroxyl carbonyl group on it. It only has this amine group, whereas thymine and uracil have carbonyl groups but not amine groups. So the amine group is some molecule with a nitrogen and 2 hydrogens. That's the primary amine, and that's what you can see here on this adenosine nucleoside triphosphate. And then the carbonyl group is what you can see here on this thymidine triphosphate and uridine triphosphate with no amine groups. The secondary amine is 2 groups here with a nitrogen and a hydrogen. So that might count for this nitrogen here as being secondary amine. So the hydrogen bonds that are being formed, there's 2 of them, and one is this nitrogen hydrogen to nitrogen, and the other is a nitrogen hydrogen to oxygen. You can see that they're slightly different strength bonds, 8 kilojoules per mole and 13 kilojoules per mole. But the main thing is that there's 2 bonds being formed as compared to guanine and cytosine forming 3 bonds. Then you kind of have a situation here with the Hugstein base, possibly that's how you pronounce it, where you have adenine and uracil forming bonds, but it's kind of backwards, where normally this nitrogen here would form the bond, but here the number 7 nitrogen is forming the bond instead of the number 1 nitrogen that would normally be there. So there's kind of a few ways that maybe things can go wrong, and this is one of them here. So if you look at like a transfer RNA, you'll see all the normal A, G, U, C, AU bonds and GC bonds. Actually, there's a few different things going on here. Right here is a GU bond, so that's when guanine and uracil form a bond. But you can see also that there's these, there's a T here and a psi here, and then some D's over here. So the psi is this pseudouridine. So that's a uridine or a uracil base that's been connected to the ribose sugar on the different node in the pyrimidine here. So normally this nitrogen is what connects to the ribose, but here in the pseudouridine, the carbon here is what connects to the ribose. So you can see here the carbon and nitrogen, and over here nitrogen and carbon. So it still forms the same bonds. There's still the same carbonyl groups and the nitrogen with the hydrogen here. It's just kind of a slightly different arrangement. The T is essentially thymidine, except normally thymidine is only in DNA, so it's called a ribothymidine, since it's thymidine, but with the ribose and the oxygen here on this number 2' carbon. So that'll be shown as a T. A T in this transfer RNA structure here. And then the D comes up as dihydrouridine. So that's the same as the uridine, except instead of a double bond here with no hydrogens, there's a single bond here with additional hydrogens on these nodes here. So you can see here, like on this uridine, there's a double bond here, so there'd be fewer hydrogens than on the dihydrouridine.